Hey everybody, this is Larry. This is the 30th day of March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Search a 2D array, or 2D matrix, sorry. Wow, how did I pass that one? But as you may have noticed by now, this week I think it's binary search week or something. So we'll see how that kind of fits together. Okay, so you have an M by N matrix. Left to right is sorted. The first integer of each row is greater than the last integer. Okay, so basically that's So basically, it's a little bit awkward though, in the sense that okay, because there are a couple of variations of this, and I am trying to make sure that I read it correctly. Because as you have known, and maybe have noticed from the last couple of whatever, I've been misreading quite a bit. So it's yeah. So the first integer of each row is greater than the last integer of previous row means that if you kind of draw it like a snake kind of way, or like a Z, but like a snicky kind of way, so that means that instead of an M by N matrix, you essentially have a 1D array that is M times N length, right? And then you could do a binary search on that one. So I think that's the way I'm going to do it. Don't know if that makes sense, but I think you just have to notice that part. Yeah, there's at least one. So then, okay. So then, what do we have to do? Find, and we have to return true, false. Okay, I just want to see if we have to return like, return the position or something like that, right? So then now we can just do, well, this is just regular binary search now. I know that I've been solving things another way, but this time I'm going to do binary search. Yeah, and this is going to be inclusive bounds. So let's do it this way. I always write it like this, so yeah. And then basically if good of mid, and what does good mean, right? So here we can define these functions however we like, but for now, and how we define it will determine how we set up the move the bounds, right? So now let's say we have good of x, or not x, maybe just let's just say t for some number, right? And what does that mean? That means that is the value at position t greater than or equal to target, right? Maybe just greater than strictly, right? And we can fill this in later, but basically now what that means is that, okay, if this is what it means to be good, then if it is greater than that, we want to keep the left side, and also that this mid position is no good, right? So then that means that right is equal to mid minus 1. And then else left is equal to mid for equal as well. And that's pretty much all she wrote. And then we just return, and let's just say f of left is equal to target, and that's pretty much it. Yeah. Here we go. Let's do, yeah, if we just return f of t is greater than target. And what is f, right? F is just, f in this case would, f maps coordinate, or a 1D coordinate t into xy, right? And so then now xy should be equal to be t. I sometimes I mess this up, so I'm going to slow down a little bit. Okay, and as long as we're consistent, it should be okay. But so t would be c, and t, this I think should be right. Okay, because the number of rows is equal to divided by the number of columns, and then now we just return matrix of x and y. I think this should be good unless we go out of bounds somehow, but it should be okay. So let's give it a spin. Maybe this time I actually get it right closely and not embarrass myself. Let's give it a submit. Cool. I feel like it's been a couple of days before I have a quick fast one. I've been making a lot of silly mistakes lately. But yeah. So the key concept of this one is that it's a little bit confusing that they have a 2D matrix, but given these properties, we can put them into one matrix, one D array, and then just do a regular binary search. And of course, everything else kind of fits in from that. Yeah. As you can guess, this is going to be log n. What is n? N is R times C, so the number of cells in this thing, and it's going to be yeah, log R times C. I guess, can we do a little bit faster? I guess so. I guess you could do a binary search on R and then do a binary search on C. That's going to be log R plus log C. Is that the same? I don't remember the map. I don't remember my identities. Like, what is log A times B equal to? Just log A plus log B, right? So I guess technically it's the same no matter what. Because log R times log C is going to be the same, right? So yeah. But yeah, that's going to be the complexity is log n, where n is R times C, because all these is just O of 1, right? So yeah, in terms of space, we only use constant number of variables, so this is also going to be O of 1 space. So yeah, cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you soon, and thank goodness for a good one, and hope y'all have a good rest of the week. Bye-bye.